All right, it's 6 o'clock. Today we plan to work on section 11.5 based on the syllabus. The first 4 sections of the chapter, we have learned the fundamental counting principle. We have learned the permutations, combinations, and we have learned the basics of probability, theoretical probability, and empirical probability. And today, this section, section 5, 11.5, we are going to combine all of those to see how do we compute probabilities if the process involves permutations, fundamental counting principle, and permutations. Yeah, permutation and combination. So let's go to Pearson. This is 11.5. Let's start. Question number 1. Those operations I'll leave you to work on your own. And later today, I'm going to assign the number 4 worksheet. It's about the fractions. All right. Yeah, I'm going to assign number 4 worksheet assignment number 4 later today. So number 3 is also about fractions. Okay, let's start from this question, number 4. Determine whether the statement is true or false. If the statement is false, make the necessary change to produce a true statement. When working problems involving probability with permutations, the denominators of the probability fractions consist of the total number of possible permutations. This is true. It is true. If the probability problem involves permutation, then the problem is a theoretical model. In a theoretical model or classical model, the denominator is the total number of possible outcomes in the sample space, and it's going to be the total number of permutations, the total number of ordered arrangements of those items. So this is correct. Question number 5. Also about a statement. When working problems solving probability with combinations, the numerators of the probability fractions consist of the total number of possible combinations. That's false. If we can change this numerator to denominators, then the statement would be true. So we are going to choose false because the denominator consists of the total number of combinations. All right. Yeah, when they have the pop-out window with the description, we should pause and read it carefully. I did not do this because I want to cover as many questions as possible, but you should read them. Question number 6. Let's see what do we have here. Don, Kim, Tyrone, Larry, Ian, Eduardo, what is Eduardo, and Maria. How many people this is? 1, 2, 3, 4, 5, 6, 7. 7 people, okay? 7 people. 7 people have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. So time, do you think this is about the permutation? Because the order of those people's arrivals make a difference, right? Yeah. So we are going to answer the following 3 parts. Part A, in how many ways can they arrive? This is the same ways you arrange 7 books on the bookshelf. You are making ordered arrangements. You are making ordered arrangement of the 7 items. So here, the total number of ways that they arrive is 7 factorial. 7 factorial. I'm going to use the calculator to find the value of 7 factorial, okay? 7 factorial is P77, or 7 times 6 times 5 times 4 times 3 times 2 times 1. Either way, Let me see, what is 7 factorial? I use the TI-84 calculator, the easiest way. And then I go to math, probability, number 4 factorial. So 7 factorial gives me 5040, 5040, 5040. Right? Part B. In how many ways can Dawn arrive first and Maria last? Let's consider this task for the numerator. What task? You are going to arrange the 7 people, right? Yeah, the result must be Dawn the first, Maria the last. So we can see the task as a 3-part task or 3 steps. First step, you arrange it down. Give me 1 second. Let me get my OneNote quick. I'm going to show you the 3 steps I mentioned. So you have 7 people. Let's say you have 7 time slots here. 1, 2, 3, 4, 5, 6, 7, right? Yeah. You are going to arrange the 7 people, but you must put it down here, Maria here. Okay. So you have 3 steps in this task. First step is to put a person in the first slot. You only have 1 option. Second step is to put a person in the last slot. You have 1 option because Maria has to be the last slot, right? And the step 3, the last 3 step, the third step is going to arrange the rest 5 people in the left 5 slots, and that is a 5 factorial. Okay, so we have this many ways to arrange those 7 people such that Dawn is always the first slot and Maria always the last slot. So 5 factorial. The numerator is 5 factorial. 5 times 4 times 3 times 2 times 1. I think it's 120. Let me double check. Yeah. 120. Let me know if you have any questions, all right? Part C. Find the probability that Dawn will arrive first and Maria last. So part C is the answer for part C is supposed to be a probability. It's going to be a probability fraction. So we have a numerator, we have denominator. Since this is a classical, as I said, if it involves permutations and combinations, then it must be a theoretical or classical model. Then the denominator is always the total number of outcomes in the sample space. In this case, is the answer from part A. And numerator would be the number of outcomes that favor the event occurring. Among the 5040 outcomes arrangements, we have 120. Those arrangements favor Dawn the first, Maria the last. So that is the fraction, right? But don't submit yet. Read the information in the parentheses. Very, very important. And I look at your test 2 result, and even I really think I emphasize many times, right? You read the information in the parentheses, I still see you lose points because you didn't follow the instructions in the parentheses. What I can do, I just keep going, right? Keep emphasizing. They said simplify your answer. So your answer is not simplified yet, okay? Yeah, you can use the calculator I showed you last time to simplify, or you can manually simplify. So when the top and the bottom both has a 0 as the last digit, we can remove the 0. So numerator divide by 10, 12. Denominator divide by 10, 504. Right? And then keep going because both top and bottom are even. So we can divide the numerator by 2. We have 6. denominated by 2, we have, it's going to be also an even number. So this, what we're going to do is we divide 12 by 4, we have 3. And then 504 divided by 4, we have 1, 2, 6. Yeah, let me double check. Yeah, 1, 2, 6, 126. And then you know what? This fraction is still not simplified. Still not simplified. Because numerator is what is it?
84.
Yeah, the numerator is divisible by 3. Denominator also divisible by 3, right? Divided denominator by 3 has 42, right? Is that the same with yours, Natalia? So also what you can do to make your job easier, use a calculator, TI-84 calculator. Enter 120 divided by 5,040. And then go to math, and then fraction, and it will give us 1/42. So that makes your job a lot easier. Yeah, I don't mind you use that. I do not mind you use technology to make your job easier at all. Okay? So let me see if you have any questions. Do we have more people join us? Okay, yes, we have Ashley and Lane join us. Any questions so far? Did you hear me about the trick using TI-84 calculator to simplify a fraction? When you take test 3, that's gonna be very helpful. Don't miss that, okay? Yeah, awesome. No questions. That all makes sense. Thank you, Ashley. Thank you, Lynn. Perfect. So let's continue. Go to question number 7. 6 stand-up comics, A, B, C, D, E, F, are to perform on a single evening at a comedy club. When I see performance, that's about the ordered arrangement. So I know that's a permutation, right? We should know that's a permutation problem. The order of a performance is determined by random selection. Find the probability that A, B, C, D. Okay, so let's think about the sample space or the experiment. The experiment is to arrange the 6 people in 6 slots. Same way you put the 6 books on the bookshelf, right? So the sample space should contain 6 factorial, that many different outcomes. Yeah, in total we have 6 factorial or P66, that many different permutations. Let me write it down. P66 or 6 factorial. Denominator is going to be 6 factorial, right? 6 factorial. 720. And we are going to focus on the numerator. Yeah, in such a theoretical model, we are going to find the following 4 probabilities when we focus on the numerator. Part A, comic C will perform 4th. C will be number 4. Okay, so part A, this is how do we arrange part A to make that happen. Yeah, 1, 2, 3, 4, 5, 6. C must be here, right? We have one way to do that. So just to put a C there, just 1, right? One way to do that. And after that, we have 5 people left, and we have 5 slots left, and multiplied by 5 factorial. So the numerator is a 5 factorial, okay? Part A, the numerator is a 5 factorial. Denominator is a 6 factorial. So the probability would be 5 factorial in the numerator, 6 factorial in the denominator, and then we simplify, we have a 1/6 because the 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1, right? And you cancel, you're going to have an extra 6 on the bottom, numerator is 1. So 1/6. Type a fraction, simplify your answer. 1/6. 1/6. Part B, we are looking for the probability that A will perform 4th and D will perform 3rd. Let me remember that. A is going to be number 4, D will be number 3. Okay, so to make that happen, To make that happen, part B, we're gonna have to do 3 things, right? 1, 2, 3, 4, 5, 6. Yeah. So yeah, I forgot already. So what is it? In order for that event to occur, A number 4, D number 3. A number 4, A is here. D number 3. That's what it says, right? Double check. A number 4, D number 3. Yeah. Okay. So first step, you arrange A. Second step, you arrange D. One option only, right? Only one way to do that. And the third step, you still have 4 people left. You still have 4 slots left, so 4 factorial. And that's the numerator of part B. Okay, so numerator is 4 factorial, denominator is 6 factorial. All the problems, all the probabilities in this experiment has denominator 6 factorial. And that gives us 6 factorial is 6 times 5 times 4 factorial. They cancel. Yeah, let me write this down. 6 factorial is 6 times 5 times 4 factorial. And they cancel 4 factorial. And you have 1 over 30. 1 over 30. Type A simplified fraction. 1 over 30 is already simplified. For C, C is the result, the event. The comedians will perform in the following order, a specific order, one order, C, A, D, B, F, E. So the numerator is going to be 1. 1 over 720. 1 over 6 factorial. 6 factorial is 720. 720. D. D is the event. F or E will perform the third. Okay, let's see this. In order for that to happen, part D. Let's see the 6th slot. 1, 2, 3, 4, 5, 6. Yeah. So for part D, the event part D to occur, comic F or E will perform the third. This slot. F or E. Okay. So we're gonna need 2 steps to complete the task. Yeah, your arrangements have F or E on the 3rd slot. And you can arrange the 3rd slot first, right? Yeah. And you either put the F there or you put the E there. So you have 2 options. This is different, right? Different from the previous 3 parts. The first step, you wanna put a person in slot number 3. You have F or E, so 2 options. And second step, you have 5 people left, 5 slots left, and that's 5 factorial. So part D, numerator is 2 times 5 factorial. Denominator is 6 factorial. So it's 1 over 3. Yeah, you figure out the calculation part. Okay, you can figure out the calculation part by yourself. There's 1 over 3. 1 over 3. 1 over 3. Don't forget to simplify. The trick I told you is the most reliable way and easy way to simplify a fraction. It doesn't mean you don't need to know how to simplify a fraction, because later today I'm going to assign the last worksheet assignment is about the fractions. You would have to show me you really know manually, okay, manually. Question number 8. A group consists of 4 Democrats and 5 Republicans. 3 people are selected to attend a conference. We are going to complete the following 3 parts. The number of ways to select the 3 people from the group of 9. Is this a permutation or a combination? Yeah, let me see if you can answer me this question. Select 3 people from a group of 9. Is this a permutation or a combination? Select 3 people from the group of 9. Permutation or combination?
Combination.
Combination, awesome. Thank you, Lane. Exactly. Because it's just about a subgroup, right? Yes, subgroup. Subgroup. The order of the three people in the subgroup doesn't matter. It's a combination. So this is C93 or C39. Let me write it down. So this is gonna be C39. Yeah, I think the correct way to read it is C39. We would read this number first and then read this number. It depends. Yeah, different book has different description. Yeah. Anyway, how do we find the value of C93? Calculator, right? Yeah, I wouldn't bother to use the formula. If you really want to use the formula, this is the formula. I don't even use it. So let's use the calculator. We go to we enter 9, and then we go to math, probability, number 3, NCR, and then enter 3. Yeah, exactly what you see here. 9 NCR, the function, and then enter 3, right? You see, it's very very consistency, like corresponds to all the 3 parts perfectly. And let's see what we have. We have 84. We have 84. We have 84 that many different ways to arrange the combination to make that happen. 84 to select the subgroups of 3. Part B, the number of ways to select 3 Republicans from the group of 5 Republicans. So this is about select 3 from a group of 5. It's also a combination, same as earlier, right? Yeah, the order of the 3 people in the subgroup doesn't matter. So C35. C35. Calculator. 5 first, and math, probability, NCR, 3, 10. 10. We have 10 different ways to select 3 members from the 5 Republicans. We have 10, that many. Part C, find the probability that the selected group will consist of all Republicans. You know, this is a very good problem because it prepares you. Yeah, the answer from A is gonna be the denominator of the probability fraction. The answer from part B is the numerator of the probability fraction. All you need to do is to simplify. All right. Yeah. Why? Because 84 is the total number of combinations of the task of the experiment. Among the 84 outcomes, 10 of them favor the event. What event? All the 3 members are Republicans, right? Yeah. So we simplify this fraction. 84, 10, they are both even. Divided 10 by 2, we have 5. Divided 84 by 2, we have 42, and that is simplified. Okay, that is simplified because the numerator and the denominator have no common factor. Question number 9. In one lottery, a player wins the jackpot by matching all 5 distinct numbers drawn in any order from the white balls 1 through 44 and matching the number on the gold ball 1 through 34. If one ticket is purchased, what's the probability of winning the jackpot? The probability of winning the jackpot with 1 ticket. All right, so let's see. What's the experiment here? You can also see the experiment as a task. Yeah, let's slow down. This problem, I got questions from this problem last semester. I'm going to copy paste and explain this problem on my note. Work. Do it again. I apologize. The device I'm using is my personal device. It's not the best. Okay. Perfect. And copy paste. Let's identify how to play the game. It's a game, right? It's a lottery game. I would see the game has two parts. The game has two parts. The first part is to get five numbers from 44 different numbers. Is a white ball. Yeah. Step 1 is play the white ball. Get 5 distinct numbers from, in any order, so it really doesn't matter. The order doesn't matter. From 44 white ball. So this is a combination. So C544. Excuse me. That's the first step to play the game. Step 2 is to play the gold ball, matching the number on the gold ball, 1 through 34. So it's matching the number on the gold ball. So it's gold. I would say pick one number from 1 to 34 to see if you match the number. So you pick one number from the 34 numbers. Yeah, let's play the gold ball. Let me read it one more time. In one lottery, player wins the jackpot by matching all 5 distinct numbers from the 44 white ball numbers on the white ball, and matching one number. The number would be only 1 on the gold ball. 331 through 30. Yeah. Okay, so that's how you play the game, right? Once you finish the 2 steps, you finish the game. So the sample space, or the denominator of the probability we are looking for is gonna be C544 times C134 by using the fundamental counting principle. Multiply them together, right? Yeah. Once you finish the 2 parts, you finish the game. So that's how many different ways to play the game, or how many different possible results if you play the game. Okay, that's the denominator. We are looking for the numerator. What's the numerator? What's the event we are looking for? The event is getting the jackpot. So from the white balls, in any order from the white balls. So in order to get a jackpot, the 5 numbers you got has to be exactly the same with the 5 numbers on the 5 white balls. And the 1 number you pick has to match the 1 number on the gold ball. That's how do you know the numerator is going to be 1. Okay? Yeah. Because C55 is 1, C11 is 1. All the 5 numbers matching that 5 numbers on white ball. So the 5 numbers you pick happen to be the 5 numbers on the white ball. It's like you pick all the 5 people from the Republicans or Democrats, right? Very similar with the problem. And the 1 number you pick exactly is the number. It's like you have magic. You know you have superpower. You know which 5 numbers on the white ball, which 1 number on the gold ball. So you pick exactly the 5 numbers, C55 on the white ball. You pick exactly the 1 number on the gold ball, C11. So that's how do we know the numerator is 1. So the probability is going to be 1 over C544 times C134. Yeah, the numerator is just 1. Denominator is a little bit complicated. Let's compute the value. Let's see what is C544. So enter 44 first and then go to math, probability, NCR, 5. We have, that's a very large number. I'm going to directly multiply that by 34 because the C134 is just 34 times 34. And we'll only make the numbers larger. The number is 3692. Are we expecting a very large number on the denominator? 36924272. Let me double check. 36924272. Yeah, we're supposed to be expecting huge number on the bottom. Otherwise, many people get a jackpot. The house will gonna go bankrupt, right? Yeah, it's gonna make the denominator super large, then the probability is super small, and the chance to get a jackpot is supposed to be small. Supposed to be small. Okay, so let's enter that number to the cell. Type an integer or simplify the fraction. So we do not need a decimal. Yeah. Do not do the thing that the question didn't ask you. So 3692. 3692. 4272. 3692 4272. Okay, yeah, and the denominator is 36,924,272. That means every 36 million, almost 37 million, around, almost every 37 million people were buyers, were investors. We have one person get a jackpot. Okay, any questions about this problem? The challenging one probably is this one. Yeah, that's the challenging one. That one, the previous problem, actually the jackpot, the numerator is easy, right? Just the one. And this problem, let's see the numerator. Not jackpot, instead a minimum award. Minimum award. I'm happy that we have time to cover those problems. Otherwise, you might struggle a little bit if you work on it on your own. All right, let's read it problem. Read this problem. In a lottery, the top cash prize was 689 million, going to 3 lucky winners. Players pick 4 different numbers. So let me highlight how does the game is played. Players pick 4 different numbers from 1 to 57. Yeah, so that's combination, right? Pick 4 different numbers from 1 to 57 numbers, and 1 number from 43 numbers. Similar with the white ball, and this part is the white ball, and this part is the gold ball, right? And that's gonna be the total number of ways to play it, or total number of possible outcomes if one person play the game, play the lottery. A player wins a minimum award. Minimum award, $225 by correctly matching 3 numbers drawn from the white balls and matching the number on the gold ball, 1 through 43. What's the probability of winning the minimum award? Turns out the top cash prize, those are, the information is irrelevant. This is about the probability of winning the minimum award. Okay, so firstly, let's write down the denominator. We should understand the denominator, right? How many different ways to play the game, or how many different possible outcomes if you play the game. So C457 multiplied by C143. That many. Yeah, you pick 4 numbers from the 57 numbers. That's the first step. Second step, you pick 1 number from 43 different numbers. That's the second step. So that's the denominator. What about numerator? Numerator is take a little time. It takes your complete and accurate understanding about the minimum award. Yeah, what will contribute the minimum award occurring? You pick 4 numbers, right? You pick 4 numbers. 3 of them, okay, 3, by correctly matching 3 numbers. So we have 4 winnings, right? Yeah, how about numerator is gonna have 3 steps. In order for the minimum award to occur, we need to have the following 3 things satisfied. 3 or 2, we will see. First thing, yeah, 3 things. The first thing, you have 3 matching numbers. Yeah, 4 matching numbers in total. So you have 3 matching numbers. You have 3 matching numbers. So the 4 numbers you draw, 3 of them coming from the 4 matching number. All right, and 1 of the number, because you pick 4 numbers in total, and 1 number is from the, what is 57 minus 4? 53 numbers. Okay, yeah, we are talking about the white ball. The first 2 steps are white ball, playing the white ball. We have 57 numbers. Among the 57 numbers, 4 of them are matching numbers. The other 53 numbers are not matching numbers. In order to win the minimum award, you pick 3 matching numbers from the 4 matching numbers, and pick 1 non-matching number from the 53 not matching numbers, unmatching numbers. Does that make sense? And step 3 is to pick the gold ball. You pick the exactly matching number from the gold ball, so C11. So the numerator is C34 times C153 times C11, and matching the number on the gold ball, 1 through 43. And let me know, am I clear? This is a difficult part. I got a lot of questions from this problem. Okay, in order for the minimum award, it's like you have superpower. Okay, thank you, Ashley. You have superpower, but you are going to only use your superpower to get a minimum award. Then what would you do? You're going to do the following 3 things, right? The following 3 things. First thing, you pick 3 matching numbers from the 4 matching numbers. Number 2, you pick the one wrong number, not matching, from the rest 53 unmatching number. Because you don't want to win the jackpot, you only want to win the minimum award, $225. And the third thing is you know which one is on the gold ball, which number is on the gold ball. You pick exactly the number, so C11. Okay, so that's the numerator. Let me compute the value for numerator and denominator, and then put it in a fraction. Numerator, it's gonna be a large number. 57. Math, probability, CNR, 4. Yeah, very large number. And then multiply that by 43. I got a huge number. 1698. What, 985,430. Let me double check. If we copy one number wrong, it's going to be very different. 16,985,430. Yeah, and that's the denominator. Numerator, C43 is 1. C43 is 4. Yeah, C43 is 4. 4 times 53 times 1. 212. The calculation part is not difficult. C43 is 4, same with C41, and this is 53. So 4 times 53 is 212. So the probability is classical. It has 212 in the numerator and 16985,430 on the denominator. You know what? I would want you to use a calculator to simplify. I would like you to, let's see if the answer decimal or fraction. Yes, simplify the fraction. So I actually want you to use a calculator to simplify this fraction because the number is very large, right? Let's use the calculator. 212. If you manually reduce, is also fine. You start from dividing both top and bottom by 2 because now we can see it's even, right? And little by little to simplify. So if we use the calculator, 212 divided by 60,985,430, and then we go to math and a fraction and enter. So this doesn't work on my calculator though. We would have to really manually reduce. So let me see. Divided by 2. Divided by 2. And the numerator would be 106. 106. And the denominator would be 16,985,000. 16,985,430 divided by 2. We have 8492715. So 2 doesn't work anymore because the denominator is not even. Let's try 3. 3 doesn't work because the numerator is not divisible by 3. 5 doesn't work. What about 7? Let me analyze 106 here. 5, 6, 7, 7, no. 8, no. 9, no. 10, 11, 13. So 106 is 53. 53 is prime. 53 is prime. And would the denominator divisible by 53? Let's try. If we divide 53, no. So this is simplified. This is simplified. 53 is a prime number. Yeah. Okay, so let's enter that. 106 on the top. And not only the numerator is not easy to find, also the result we have to simplify. Denominator is 8492. Be very careful if we enter something wrong. 715. 715. I hope this is correct. Should be correct. 8492, 715, 106. It is correct. All right. So don't forget this problem. Watch the video if you don't get it completely multiple times to really get it. Then you don't struggle. You don't struggle when you work on the problems. Number 11. A box contains 13 transistors, 4 of which are defective. If 4 are selected at random, find the probability of the statements below. Find the probability of the following events. Okay, part A. All are defective. Okay, so all are defective. So this is a box. So this is a combination problem. Okay, combination. Let's find the denominator. The task here or the experiment here is to pick or select 4 at random from the 13. So C4 13. Let's see what is the 13. C4 13. Enter 13 first, and then go to math probability, NCR, 4. I got a 715 as denominator, 715 as denominator. And the numerator, let's see, how many of them contribute or favor? All the 4 randomly selected items are defective. So 4 of them are defective, and you have to pick out the 4 defective. So C44 is 1. C44 is 1, and that's the probability. Part B. Part B is to find the probability of none of them are defective. So remember the same experiment, so the denominator is going to be the same, 715. Let's see what's the numerator. Numerator, how do we make the numerator happen? Yeah, how do we make the result? What result? None of them are defective happen. Means that the 4 items you select are from the 9 items that are not defective. So 13 transistors, 4 of them defective, 9 of them are not defective, right? Are perfect, yeah. So 9 of them are good, So you have to pick all the 4 from the 9. So C49, C49. So enter 9 first. Go to math, probability, go down NCR, 4. Enter 4 again. Yeah, 9 NCR 4. I got a 126. 126. Let's see how do we simplify. 2 doesn't work. 3 doesn't work either. How do I know 3 doesn't work? Because the numerator, yes, divisible by 3, but denominator, no. 715. How do we know if a number divisible by 3? This number has 3 digits, right? If you add them up, it's a trick. We got a 13, but 13 is not divisible by 3. So 715 is not divisible by 3. So 3 doesn't work. 2 doesn't work, 3 doesn't work, 5 doesn't work because the numerator is not divisible by 5. 7, no, denominator is not divisible by 7. 715, let me analyze it. This is the trick I teach in algebra class, very useful. If I divide by 5, I have 143. 143 divisible by what? Is 143 a prime number? Let's see. Is 143 prime? Let's try 11 here. 11, so 1, 3. Now it's complete. Cool. Okay, so the denominator is 715. Numerator is 126. 126. And the denominator has 3 factors, prime factors. And numerator is not divisible by 5, is not divisible by 11. Is it divisible by 13? Let's try. 8, 13, 126 divided by 13. It's not either. So this is already simplified. It's already simplified. Let me double check with the calculator. 126 divided by 715. Go to math, fraction. Yeah, it's already simplified. I would say the calculator is good, but not completely 100% solve your problem. You would have to know some knowledge from algebra that help you to determine if the fraction is simplified or not. So it's already simplified. Okay. Yeah, time's up. We have more questions. If other questions any questions are challenging, feel free to email me and ask. All right. Yeah, we're gonna stop here today. Tomorrow we're gonna go to new section 11.6. And again, later today I'm going to email you with the worksheet number 4. Okay, guys, have a good evening. I'll see you tomorrow. Thank you for coming today. Okay, thank you. Thank you, Ashley. Thank you, Lian.